Welcome to Radio Friends on this Friday, November the 7th. We've got one guest today and a very interesting one. Jack Schultz, Director of the Life Science Center. Welcome back to Radio Friends.
Good morning, Paul.
Yeah, and we were talking, the KBIA is in the middle of the fund drive, the membership drive right now. Mm-hmm. By the way, if you want to make a pledge, it's 882-91-FM, and you told me you're
members, of course.
Yeah. Mm-hmm. But we're here to talk about all the different aspects of that Life Science Center. You came in today, you said, you ever wonder about the fall colors? And tell me about the fall colors.
Well, everybody wonders about the fall colors. In fact, we get a lot of calls at this time of the year, people asking questions about it. I've done a couple of interviews. The mystery for most people is not that it happens, but why it happens. And the why question takes two forms. One is, what's happening in the leaves so that they change color? And the other is it good for something?
Is it what?
Is it good for something?
Yeah.
Does it serve a purpose?
I know why
of some
it
sort?
happens.
Come on.
Can you test me on that?
Sure.
I think the color that we're seeing in the leaves is the actual color of the leaf. Mm-hmm. But when it's making the chlorophyll,
mm-hmm.
which is green,
mm-hmm.
it's actually masking the true color of the leaf. When you go into fall, the chlorophyll is not being produced, and the true color of the leaf comes through.
Right there.
Is that right?
You get an A, or maybe an A minus. The only thing about the minus is that the chlorophyll is actually being broken down. Chlorophyll is really valuable. It's got nitrogen and other goodies in it, so the tree wants that back. So the tree actively breaks down the green chlorophyll, reabsorbs it, sends it down to the roots.
I didn't know that. It
sends the parts, the pieces, down to the roots to store for the winter, so it can use it again next year.
So when the leaves start turning color, the tree is kind of feeding itself like a bear to hibernate for the winter. Or
saving up anyway. Yeah, saving up for the spring. And you're right, most of those other colors were there all summer. Maybe not quite as bright as they are in the fall, but most of the chemistry that makes those colors was there all summer. But it looks as though the tree made that new. But it turns out there's really no evidence that the trees make those colors from scratch in the fall. They appear to have been there for most, if not all, the season. So, is there a function for turning red or yellow in the fall? Well, lots of people have ideas about it. Some people think maybe it repels insects or relates to some kind of stress the plant experiences. It turns out nobody can really back any of that up. Those chemicals were probably useful to the tree during the summer, serving various kinds of purposes. But the change to that color in the fall is mainly the loss of green, and nobody's been able to uncover something that improves the life of the tree by turning color in the fall.
But that chlorophyll that it's breaking down is going into the root system.
In pieces. It's breaking
so
it
that
in
it
pieces.
Can use it again. The tree, is it doing anything during the winter time in sub-zero weather?
No, it's pretty much shut down. And now that's not so true of evergreens. Evergreens can perk along doing a little bit of photosynthesis.
But like the mighty oak tree has shut down.
It's shut off for the winter, yeah.
Okay, all right.
Which is a good way to get through the winter, like hibernation, as you suggested.
Like the bear. Sure. The other thing we wanted to touch on, what about virus and flu?
Well, are you feeling yourself this morning, Paul? You okay?
Yeah.
Did you get your flu shot?
I did.
So did I. Actually, you're not entirely yourself. About 8% of your genes are actually virus genes.
8% of my genes are virus genes.
If we go through all your DNA, about 8% of it will actually not be your human DNA. It'll be DNA from viruses.
Okay.
And some of those viruses have been in there, riding around in your cells as pieces of DNA for millions of years. In fact, we share some of them with the apes. Mm-hmm. Okay. And that just illustrates that we've been attacked by viruses ever since we were here. And our body keeps shutting them down, and new ones appear and pop in and invade us. The flu virus doesn't really act that way. It kind of comes and goes. But there's a really interesting characteristic it has, and that is that it evolves really fast. So every time you're infected by a virus and you shed viruses and pass them on to your friends and neighbors, you're passing on viruses that are a little different from the ones that infected you. This is why you have to get a new vaccine every year, because the characteristics of the virus change enough from year to year that you can't develop a vaccine that covers them all over the years.
So your body is only immune for that 1 year.
That's right. Mm-hmm.
You're not making antibodies that are going to...
Well, you are against the virus that was most popular or most common this year.
Mm-hmm.
But there are probably others out there. This is why you can still get sick, actually, even if you get your shot, because not all the viruses are the same, and the vaccine is aimed at the one that's most common.
Mm-hmm. So by getting the shot, you're reducing your chances of getting sick.
Greatly, yeah.
Are you giving yourself just a little bit of the flu when you get that shot?
Well, you're telling that the vaccine is telling your body that there might be viruses there, and it should gear up to fight them. And so, and moreover, it tells your body what virus it is. Okay, so the vaccine contains proteins that have the information about what the virus is and tells your body, get ready to fight it. So yeah, you're increasing your immunity by getting this shot.
And it takes about 2 weeks for that to take full effect?
Yeah, mm-hmm. Yeah. And then next year, it's a new virus, new vaccine.
Yeah. Now, I read somewhere that they're working on a shot that you would just get one time in your life, and it would take care of you. How close are we to that?
Not very. The virus has an almost infinite ability to change the few proteins that code it, essentially. And those are the proteins you aim the vaccine at. And gee, each protein is big enough and has enough parts to it that tinkering with a little part can make the vaccine not work, but the virus works fine. Nobody has yet figured out something that's broad enough acting to account for all the possibilities.
But hopefully it will someday.
Yep.
Well, the next time you come back, I'd like to talk about antibiotics and the overuse of antibiotics and what we are doing to create these superbugs.
One important thing about that is everybody needs to remember antibiotics don't work against viruses.
Right.
Vaccination is the way to go.
Yeah. Okay. Thank you so much, Jack.
My pleasure.
Always a pleasure having you, Jack Schultz. Oh, it's a pleasure having you. And I found out that I did know just a little bit about the color of the trees.
You'd get an A.
No, you gave me an A minus, you said. All right. Hey, listen, if you enjoy listening to KBIA and you enjoy this program, please consider making a pledge during the pledge drive at 882-9136. And we thank you in advance for that. Tomorrow, League of Women Voters and MU Theater. Our program directed by Travis McMillen of the Reynolds Journalism Institute. Audio is Pat Akers from KBIA. Our floor director, Lowell Thomas, and our assistant producer and guest coordinator, Uncle James Mauser. We'll see you tomorrow, 882-91 FM. Bye-bye.